Well, happy Wednesday. We're on to Chapter 8, Working with Inheritance. There's more in Chapter 8 than we're actually going to get to. The second programming course, if you do continue on, the object-oriented programming in Java, is going to take a much deeper dive into inheritance and actually finish out all of the stuff that's in there. So for our purposes, we're going to look at some of the basics and look at a couple examples, just so that when we get to building Java FX applications, when we use inheritance, it makes sense. Because otherwise, it's just kind of like magic things that you type in. So we'll talk about inheritance, do a little bit of basics of it, and then it kind of rounds out the fundamentals of object-oriented programming here. One of them is inheritance. So we'll talk about that. We'll do more examples with testing, so we can look at writing our own unit tests. And then next week, Monday we finish up inheritance. Wednesday we start arrays and collections. Now we're only hitting just the array list portion of that chapter 12. So we're going to do arrays from chapter 11 and then array lists from chapter 12. And then we got the midterm coming up. So today I'll give you last semester's midterm. And just this is the kind of questions it's going to be, the format. I had a discussion last night with my Tuesday class, and I'm opting towards not having a set time limit from when you hit start to when you hit end on it, and have it just be open all week long like the chapter quizzes are. I think that'll be a better format, a little bit less stress then, so you're not, trying to code this particular problem in some set amount of time. I think that'll work out a little bit better. But that means that they have all the Tuesday night session, and we only have set aside the Wednesday. So I think we might end up bumping that to take like the Wednesday and the Monday, essentially, for the midterm, to give you folks time to work on it. So it's 4 hours of in-class time, just like the Tuesday night class has. So it'll bump things down just a little bit for us, I think. But that's fine. We got enough time working with all this extra Java FX stuff here. If we bump that down a little bit, we should be in pretty good shape still. So I'm going to update this. So we'll set aside the 27th and the 1st for the midterm. It shouldn't take you longer than that if you just want to dedicate that in-class time to it. It's open book, open notes, open internet. If you can Google the answer to the questions, that's my fault. I wrote a bad question, right? For the long answer style questions. It's two parts. The first half is like quiz style questions. So it's 15 quiz style questions. And then it's 3 long answer questions. So I'll go over some examples of what that might look like, what those questions look like in a second. We can do that. Oh, I forgot. I didn't bring the other laptop. I got to put chat here on my phone, so don't forget. So I've got, I still have that example. Oh, no, I trashed it. I bring that back.
You got some scissors?
I don't see any up here, actually. No, I'm sorry. I have staple remover. It's sharp, maybe. I don't know. Gonna try. Yep. All right. So this was last semester's. Actually, 16 questions and then 3 long answer. The first one here is just acknowledging our academic integrity policy. It's open book, open notes, open internet, but you cannot work with other people on it. Right? That would be a violation of the policy, and you would fail the course. So I'm going to trust you folks to do the right thing, not have a separate WhatsApp conversation or whatever people use for chatting here to ask each other questions. So this is your individual assignment here. And then all work is your original unless otherwise cited. So if you do find something and you cite your source, we're cool. Right? English paper style rules. Cite your sources, we're good. Okay? It's my job to write the questions that you can't Google them. Right? So like you shouldn't be able to Google these long answer. The 15 quiz style questions, I used to write my own, but I think I've convinced myself that using the test bank is not the worst thing in the world, and it's going to tie itself very well, like right to exactly what's in the chapters here. So the questions will be quiz style format, not these true-false style questions, but there'll be 15 of them, and then we'll get some long answer questions. One about loops. We haven't talked about writing to files yet, so ignore the file portion of it. So it'll just be a question on loops. The book we used to use did loops and files at the same time in the same chapter. I don't know why. Sure. And our current book does files later. So we'll come back to files later. So a question about loops, like, hey, ask them to enter something and do something with it. Just a loop. Okay, nothing super crazy here at all, right? Just a quick little write it. And then a question like, write a method named plus minus multiply. Requires 4 integer arguments. Adds the first 2 together, subtracts the third, multiplies by the fourth, returns the result. So write a quick little method that has some arguments for something. And then the last one is write a class. Here, in this case, this was flower. It has private attributes for name, color, smell, and number of petals. Have get methods for all the attributes. Add a method pick a petal, which reduces the number of petals the flower has, but does not allow the number of petals to go below 0. So similar to what we're doing for our project, we're writing a class. There's no tests happening here, and this just has one little interesting method like pick a petal that interacts with the attributes. That's it for the midterm. And it's hopefully you're looking at that and thinking it's not too big of a deal, is sort of the goal. But this is a chance to do an individual assessment. I'll have it untimed. It's like so we'll start it on 10/27, and as long as you get it in by 11/3, we're good. So you'll have the whole week, both class sessions to work on it. Given it's open book, open notes, open internet, you're welcome to come in here and use the computers if you want here, and let me know, and I'll come and sit and watch you take it. Otherwise, I'll plan on not being here, because you can do it whenever you want. That should be fine. So we'll do both 10/27 and 11/1. I'll get this updated. Okay, I can do that now, actually, so I don't forget. We'll get that updated here, and we should be fine. It's the Monday, Wednesday. And then our project is coming up due before that, right? We've got project 3 due on 10/20, right? 10/20? Is that right? Let's check that date. No, 10/25. So it'll be due before the midterm on 10/25. And then it'll be out of the way. So the only thing you have to do that week is the midterm. It should be nice. No project to work on. Just practice, get ready, prep for the midterm, and take it. How did I end up? Oh, we pushed these back a little bit, right? Yeah, because we're doing them on Mondays is why. That's why. Yep. All right, so for midterm, we'll do an extra week of midterm here. And bump these ones down. I'll move this one, add it too. That'll make a little more sense. We did Mondays for those. Okay. So then this one gets bumped down. That one gets bumped down. And then our final project on the 17th. Yeah, that gives us still a month to work on it. Easy. I like that. All right, so that'll be the new version here. Let me get that uploaded. All right, so we should get our latest and greatest version here in D2L. Make sure that's good. It's still loading. Here, I'll put up the midterm practice over here in D2L. Grab our midterm. Here we go. All right, so the practice midterm's out there. If you want to take a look at that. And then for question on loops, ignore the file part of it. Okay. So it'll be untimed. Submit anytime before, what is that date? 11-3. How about between? So if we start it on 10:27 p.m., as long as you get it in by November 3rd. So I'd like them before class starts so we can go over answers to it though. So like our quizzes usually are 11:59 p.m. This one have in before class starts, but shouldn't be a problem. You've got 2 whole class periods to work on it. I should be able to get it in. Okay. All right, questions, thoughts, concerns? I'm feeling all right. Practice midterm? Makes sense? Okay, so that'll be the format. Yeah, please use NetBeans for the coding questions and like just copy paste your code in. That'll make life easier. I still have people sometimes who just try and type the code out like in text boxes in D2L, and that's awful. Like, trying to type code into those text boxes is it's definitely not an easy way to write code. Oh goodness, this really needs to be like more desk-like. I guess I want people to stand. All right, so we fire up NetBeans and we can start some new stuff. Talk about inheritance. Oh, and the winter schedule is out now. I saw on online services. You can't register yet, but you can go and look and see what classes are offered when. So if you are continuing on, it's worth looking at real quick. The 2151 course is offered next semester. There we go. So you got 2 options. One, if you want to stay here at Orchard Ridge, take a class with me again. We got Tuesday, Thursday instead of Monday, Wednesday. We're moving over to Tuesday, Thursday, 10 to 11:50. Still planning on doing this high flex experiment thing. It's going well. We got a couple other faculty members trying to do their own version of high flex. They like Zoom. Sure, there's nothing wrong with Zoom, I guess, but I just think Twitch is more fun. Or out at Auburn Hills, Tuesday nights. Your options for 2151 if you're going to continue on take the next programming class. Technically, you can take data structures without having taken 2151. The only prereq for data structures is 1500. I strongly recommend, and Dr. Baugh strongly recommend, you take 2151 before taking data structures. Right? Having a second semester of Java under your belt, getting into these fundamentals of object-oriented programming, doing more with inheritance, and the rest of all that stuff is going to put you in better shape to do data structures. You don't need to, and some people don't, and they do just fine. But if you can work it into your schedule to take this one after 2151, you'll be in better shape, for sure. Cool. Yep, anything, I think everything else is out here. We should be in pretty good shape. Any questions about the schedule? And there is something, I didn't get all the info yet. Our provost sent us, we got federal grant money for student assistance. And she said, all you have to do is ask for it. So it already passed for the fall, but whether or not you're getting financial aid or not, after you register, you get an email. And apparently a bunch of students thought it was spam, which sucked. She said not everyone asked for it in the fall semester. You just say, yes, I want money, and OCC will send you a check or direct deposit. If you're getting financial aid, you'll get more. But if you're not, I think it was like up to $400 or something, just free aid, thanks to the federal government. So when you do register, look for that email. I'll have a little bit more info. She said she'd send us like what the email would say or the subject in it, so we can let you folks know. And essentially that pays for like one class, right? Or at least one 4-credit class. That's the tuition cost, right? Up front. So that's pretty sweet. All right, so thinking about fall already, man. I guess it's mid-October now. It's That's fair, right? Thinking about winter? I said fall. I mean winter. A little tired, folks. I need some more coffee. All right, NetBeans finally loaded. Sweet. So let me close this one down. Fire up GitHub here. Trash that one real quick. Discard all these. All right, sweet. Discard again. There we go. All right, so I'm going to start a new project for Chapter 8, Inheritance. Chapter 8, Inheritance. Looks right. Let's get it in here. So inheritance is all about using classes and kind of taking some shortcuts, trying to not reinvent the wheel. So again, we're not going to put anything in main yet. Right? When we're dealing with classes and writing our own classes, we just leave this main method alone. We can come back to it later. What we're going to do is come back to our project, open up our source packages, open up our package here, right-click, add a new file. So we're going to write a class here that's going to represent, how about like a product that we sell. So we'll write a class here for product. Now, if I'm going to sell something, what are some attributes about the things that I'm going to sell that you think we would track here in code? What private variables is this class going to have if it's something that we sell? Yeah, sure. So it'll have a private double for price. Again, you probably care about the pennies, so double, it can hold a decimal place, makes sense here. Quantity, sure, we can have that. Private, is that an int for quantity? Or can you have like fractional pieces or something? I don't know. I'll go with an int for quantity. Sure, like 1, 2, 3, 4 of this thing here. What else do we know about products that we sell? Like the cost or like yeah, we got quantity for like how many of them, What about the name? You want to know what you're buying? Okay, sure. So a private string for name. Now, something that we probably are going to care about here, if we're selling something, now, are we just like a reseller? We're going to buy something wholesale and then sell it at markup like a grocery store does? That's a quick, easy way to make money, right? Rather than manufacture the product ourselves. So maybe we have a double for, what is it, like our cost here? Cost versus price. So maybe we can be specific. This is like the sales price, and this is the cost, right? So our cost to buy, I don't know, our cost or something. We can be specific here. So if I know how much it costs me to buy it at wholesale, and I know how much I'm selling it, right, that's good. Those are good things. Right? I know the name and I know the quantity. How many of them? Sure, we can do all that. So this is a pretty good list. We can come back to and add more if we want, but I think this will get us to where we need to. Now, all of our attributes here, if someone needs access to them, we need to give them a public get method, right? A way to get the value from us. So I'm going to right-click and go to Insert Code and say Getters, and I want all of the getters, right? I want you to be able to get the sales price, get the quantity, get the name, get the cost to buy, get those values. Now, which of these makes sense for us to change, right? Like once I have the name of an item, is that going to change? Probably not. So I don't need a set method for name. Right? You only add set methods for attributes that should change. Once I buy the item at wholesale, is my cost to buy it going to change? No, probably not going to change. So I don't need a set method for cost to buy. The quantity, like how many of them I bought, that probably is going to change, right? If I sell 2 of them and I still have 5 more, right? So the quantity, this is more like our quantity on hand, maybe, is a better way of saying that. Right? How many do I have available to sell? Oh, in here, let's right-click, refactor, rename. We'll change that to quantity on hand. And it renames the get method for me too. Look how smart that is. Love this tool. No, it's quantity on hand, get quantity on hand, quantity on hand. So don't like rename it yourself, right? You'll just call it more work for yourself. Now the sales price, Is this ever going to change, right? If I say, hey, initially I'm going to sell this thing for $1.50, and then we put it on sale, which is kind of a misnomer because like if you're selling it, it's already on sale because it's something you're offering to sell. But what we usually mean by that is there's a discount, like, hey, it's 10% off today, right? Because we want to encourage people to buy things. So our sales price could probably change, right? So we probably need a way to set the sales price and a way to set the quantity on hand. So when I add some setters here, only the attributes that should change need setters, right? So I'm going to change my sales price. I'm going to change my quantity on hand. Those ones make sense for this class to be changeable, right? You're not changing the name. I'm not changing how much it costs me to buy them at wholesale here. Okay? Does that make sense? So we don't always need set methods for everything. It's just whatever our class determines is going to figure that out for us. Whatever our class is representing, if that value is changeable, yes, have a set method or some other way of changing it, right? For our vehicle, right? We're not directly saying, hey, I'm going to set the amount of liters in the tank, right? We're saying, hey, I can add gas is a way to increase the liters in the tank, and I can drive, which is a way to decrease the liters in the tank. That's how we interact with it. There is no, hey, car, vehicle, all of a sudden you now have 15 liters in the tank. It doesn't work like that. Right? You can go and add 15 liters, or you can go drive a bunch and use up 15 liters worth of gas if you drive far enough. Right? So the way that we interact with it totally depends on what the class does and what makes sense for the class. Right? What is this noun that we're representing? So now I need a constructor method. Remember, constructor methods are the special methods that create an instance of the class. So if I don't have a set name and a set cost to buy, those have to be arguments in the constructor. Right? To make an instance of product, you have to give it at least the name and the cost to buy, because there's no other way to change them or set them or to give them a value. Right? The only way I can say, oh, this is the name of the product and this is the cost to buy it, is through the constructor. Right? The sales price and quantity on hand probably makes sense to put in the constructor too, because I probably know all of those things. Like, okay, this is how many I bought, and this is what I'm going to sell it for. But you can also change it after the fact. When we want to add a constructor here, so insert code, go to constructor. I'm going to pick all of them here. I want all of these to be passed here. Again, the ordering's a little bit funny here, so I'm going to change it. I want the name first, and then I want the quantity, and then I want my cost, and then I want the sales price. How about that? You can pick whatever order you want to put these things in. Perfectly fine. Right? No big deal here. And I think this will be easy. So the name, the quantity, the cost, and then sales price. Now, our set methods, right, can also do some sanity checking. The idea that we've encapsulated all of the details of this class into one nice little package, right, and we're giving people a public interface to interact with so they can interact with us abstractly. This idea of encapsulation and abstraction. We need to ensure the integrity of our class. We need to make sure that our product never gets into a bad state. And a bad state might be if someone says, hey, your sales price is negative $1, which would mean now we're paying people $1 to buy our products. And I don't think there's products like that people pay you to buy them, right? Unless it's some weird multi-level marketing scheme, maybe. Maybe then they're paying you to take their products. But sure. So we can do some sanity checking and some validation to make sure we are only getting good values here. So when we set the sales price, we can check. We can say, hey, if the sales price is less than 0, that's no good. Maybe we'll just default it to 0. And then otherwise, we'll take the sales price. Oh, and it's sales price is the orange one here, right? That's the argument sales price. So I really need this dot for my instance attribute sales price. That's the green one. So this current product that I'm calling set sales price on, I want to set the this sales price, not the argument sales price. Remember, it does this shadowing thing. And we can do the same with quantity on hand. We're never going to have a negative amount of something on hand, right? Unless we really screwed up somehow and I promised so many people I'd sell them a product and I don't actually have it in the shop. But again, that's, we'll try and be better than that. So if the quantity on hand is less than 0, then our this.quantity on hand will just set to 0. Otherwise, we'll take the quantity on hand they give me. Okay, so our set methods, or any methods that are changing our attributes, can make sure we're making some sense here. That they will keep our object in a good state. So we have integrity. So we're getting a little warning here, or a suggestion saying, hey, you could make this field final. We talked about that a little bit. Final fields you set once and you can never change again. The code prevents you from doing it. So if you want it to be set only in the constructor and never changed again, you're welcome to mark it as final. We're not going to bother. Right? That's something, again, you can play with more next semester. It's not wrong, and it will keep you from changing it by mistake. But again, that's just another thing we don't need to care about right now. So don't worry that it's saying, hey, you could make them final. You're welcome to if you want, but it's no big deal. All right, so we've got product. Right, so now what we used to do is we'd come back over here to main, and we'd say, oh, now let's do something here in main. Right, so we could, I don't know, make a scanner, call it keyboard, it's a new scanner, given system.in, and then we'll have to ask the user, what's the name of the product you want to sell here? Oh, we got to import our scanner. Thank you, NetBeans. And then we can have a string for name is keyboard.nextLine. Sure. And then we have name. We have what? How many? Any of the product do you have to sell? Sure. And then that's a int for quantity. Use an integer.parseInt of the keyboard.nextLine. Okay. Parse, isn't it? ParseInt. Oh my goodness. Folks, I have not had enough coffee yet this morning. Sure. And then we need some doubles here. So how much did the product you have to sell cost to buy? Sure. And that'll be a double for cost. And that's double.parse double. Double.parse double. Right, and then how much are you going to sell it for? The sales price. How much are you going to sell the product for? Sure. Right, then we go to sales price. Now I have all the attributes that I need, all the values I need. Now I can make an instance of product. Right, so I say product, like my product or just lowercase product, sure, equals a new product, given the name, the quantity, the cost, and the sales price. Right? These are my arguments here, name, quantity, cost, sales price. When they get handed to the constructor, it's called name, quantity on hand, cost to buy, sales price. Right? The names don't need to match. Just because I call it name here doesn't mean I need to hand it a variable named name here. Just use whatever variable name you want for it, right? But inside this method, this is what I'm calling the argument that was given to me, right? Just like when we talked about with methods. So we're going to make a product. Awesome. So now we can do that. And sure, now we can let's just print out the product. Let's print product. Now let's give this a run. So we didn't actually print out classes last time, right? We didn't get that far. That's all right. This is good. It's good. We're getting to inheritance. We have to set the stage with the class first. So what do we want to sell? I'm hungry. I'm thirsty. I want some coffee. We've got like 10 coffees to sell. It costs 50 cents, right? If you buy, even less, like 25 cents if you buy the grounds here, and you can sell it for $2 if you brew it. Add a little water here. Compile on save thing is killing me. It's the worst setting ever. Try that one more time. So coffee, we got 10 of them, we have 25 cents for the grounds, we're going to sell it for $2 here. Oh. Chapter 8 inheritance dot product at something. If you try and print out an instance of a class, you generally get garbage, at least for your own custom classes, right? But we got something though. That's weird garbage. Remember, if you go to your product and you say product dot, or your instance of that class and you say dot. See, there's a bunch of methods that are bold and a bunch of methods that are not bold. So the ones that are bold come from the product class. These are the ones we wrote. There's one called toString that comes from java.lang.object. So behind the scenes, every object in Java implicitly inherits from this class called object. And what inheritance does is it creates an is-a relationship. Now, you might be familiar with inheritance, and this is a relationship from like biological classifications. Remember, if you talk about biology, you have kingdom, phylum, class, order, family, genus, species. Like all mammals, right, are a type of mammal, but humans and dogs are different kinds of mammals. We're both mammals, so we are mammals, that we're an is-a of a mammal, but then we're a distinct type. We're a unique, special version of that mammal, right? So inheritance is that same thing. So we are a type of this parent class here, so we are a type of object, so we do all the things object does. So it turns out Java has a couple things built in to, if you want to represent a class as a string, the default that you get here is the name of the class and its memory address. This is where this thing's being stored in memory. Right? 6D31113334. Sure. That's where this is stored in memory right now. How fun is that? But again, it's not a very useful toString here, but it's there so that it at least doesn't crash because through inheritance, which is fun. So what we could do instead then, right, is we'd want to go and actually get all those values back out. So we could do like product.getName. Here's the name plus, and append that one in, and then maybe we'll do our product get quantity, the quantity on hand, and then we'll do the price or the cost to buy, right, will be the cost to buy, and then we'll get the sales price is the product dot get sales price. Sure. Now, if we get the individual values out, those ones we can print nice and easy as we can do the string concatenation like we've done before. So for this given product, right, for our coffee here, we got 10 of them, 25 cents. We're going to sell it $2 a cup. Right, we get all of our values back out. Prints it nicely here. Sure. The other thing we can do, right, I can make a product. I don't have to do user input. There's no rule that says I need to ask the user for something. If I know what it is, I can just put it right in my code. So for our product here, if we're going to sell espresso, we can make it a new product. We can call it espresso. Espresso. I think that's right. So espresso, then we've got maybe only 5 of these here, and maybe it costs 75 cents for the espresso beans, and we sell this for $2.50 each. Sure. Now I have an instance of the product class that I'm calling espresso for my variable for it. Now, to print out all of its details, I'd have to copy paste this and change product to espresso. We could do that, but I'm going to feel bad about myself because it's essentially the same code twice, right? And anytime you have the same code twice, you should feel bad about yourself. That's a good rule of thumb. So what we can do instead is we can write a method, right? We can still put methods in the class that has public static void main. They're just static methods. We don't have an instance of chapter 8 inheritance. We don't never make a new one of these things. All our methods are static, right? They're defined once for the class. So we can say, okay, public static void, how about print product? And what you can give it as an argument is a product. We'll just call it product. So if you give it an instance of the product class, it can go act on it. So we can take all of this here, cut it out, paste it in here. I'll say, okay, I want to print product given the product. And then over here, I want to print my product given espresso, the espresso instance of the product. Now, you might remember a while back we talked about methods and passing arguments and how arguments are passed by value. Or if I pass an integer, I'm passing a copy of the integer. Right? So even if you change that integer, it's not changed in the original. Does that ring a bell? We did that one with methods. So when you create an instance of product, out here in memory, product, it goes and asks Java, or Java goes and asks the operating system for some place to store it. So it says, oh sure, how about x32fb? Here's a memory address. Go store it here. Oh, thank you so much for the reminder to hydrate, Wolf. I've got my Coke over here. I will grab it in just a second. What it's storing here then is a string for name. Right? Now the string for name when you store a string, it says, oh, somewhere else out in memory, how about x29fa is coffee. And what this string that we're storing inside of product is literally the memory address, x29fa. Right? And it says, hey, go look over here. So what is stored in the product variable is just where that string is somewhere else in memory. And in 64-bit systems, that takes up 8 bytes. Right? Every memory address is 8 bytes, because that's where that memory is. So we're storing that. Then we had a integer, right, for quantity. Right? Integers take up 4 bytes, right? 4 bytes of memory. Okay. And then we had a double for the cost. That takes up 8 bytes. Now, the integer quantity and the double cost, those are actually put right into this location in memory. There is no, hey, here's a value somewhere else out in memory. It's in this 4 bytes here that I have reserved for you, you can put your value because it's a primitive type. And then same with our double for sales price. So we have 8 bytes here. Right, this is our sales price. So when we create an instance of product, and I write a method that says, hey, you give me a product. Right? What we give it then is the value of that product variable. So in our case, the value of this variable called product is this memory address. We're saying, hey, it's at 32 FB. Bless you. That's what we give it. So if I give you the memory address of where that class is stored in memory, you can go call methods on it. Right? And we can do all the same things. So I can say, hey, sure, let's call get name, let's call get quantity, let's call get cost to buy. And we can do the same operation on a different instance of the object. So in this case, we're going to do it for the first product that we asked the user about. In this case, we're going to do it for our espresso that, hey, we know we're a coffee shop, we're going to sell espresso. So we're going to sell coffee, cost me 25 cents. Oops, how many of the product? Not 0.25. That was the wrong prompt. Coffee, 10 of them, 0.25. We sell it for $1.50. Right, we get the coffee, and then we get all the espresso details. Right? Each one works. So you can write methods that take instances of classes as arguments, which is really cool. So if we're doing the exact same operation, but it operates on a different instance, we can change it. Right? Now, we could also do something like, let's go and say we want to put everything on sale. So let's make a method here, static void, reduce product cost. Given a product, we'll just call it product, and then how about given a double for the, the percentage off? Percentage off, right? So if we say, hey, something is 10% off, right? We can change the sales price. So I can give the current sales price here, so double is the current sales price, is going to be my product.getSalesPrice. Now, when you ask people for the percentage off, if they say something is 10% off, they're going to give you 10%, right, which is 0.1. What we really want to do is take the price and subtract 10% of the cost from that, right? That's 2 steps. We could, or you can say 1 minus the 10% gives you 0.9 remaining, and that is how much of the cost is the new cost. That, it's just that arithmetic there. So our new sales price is going to be the current sales price times, we can say 1 minus the percentage off. Right? Does that make sense? Right? So if it's 10% off, 1 minus 10% is 0.9, so it's 90% of the original price. Right? Either any way you want to do the arithmetic is fine. And then what I can do is I can say product.set sales price given the new sales price. I can change the price here of the product. Because I have the memory address of where this product is in memory, any method that is going to change a value is going to let me change the value. So if you pass objects, they're not immutable, right? Then your methods can go and change them. When we passed a string, we passed the value of the string, which was the memory address, but strings are immutable. I can't change it. There were no methods to say, hey, change the value of this string here. All of the methods on string would make new strings in memory. So that's just something to keep in mind. if you're passing objects around and you have methods that let you set or change values, wherever you pass them can set and change those values. So we print out our espresso, and then we'll say espresso is now on sale. And then we'll say we wanted to put product on discount, reduce product cost. I'm going to reduce our espresso by 10%, and let's print it again. Let me give that a little format. Right, we should, nope. There we go. Format. We should see it goes 10% cheaper. Right, so let's sell coffee, sell 10 of them, 25 cents, $1.50. Here we go. So the espresso was $2.50. Now the espresso is $2.25. Right, 10%. Right, 25 cents off. That worked. Okay, it's now on sale. Hooray! You can get your cheaper espresso, which is awesome. You get a free drink every year if you sign up for their Starbucks rewards thing. And I would always get, there's a particular drink I like called the flat white drink. So it doesn't have any of the foam in it. And the large usually has like 4 shots in it, because that's their large already. So, and I would always get more shots for my birthday reward, or if I got a free drink. So I would usually get it with like 8 shots. Right, so 4 extra shots. That's a lot of shots of espresso. And like in the app, it saves your usual drink. So one time we were driving along, I think we were going to the zoo or something, and I asked my wife, hey, can you order me my usual drink? And she's like, oh, sure. I was like, I got the free reward. I got enough points for it. This is before the pandemic, when I used to go out a lot and drive places. Now I don't go anywhere ever. So she's like, oh, okay, usually you get it with 4 extra shots, right? I said, yeah, if it's free, I can add all the extra shots. They don't charge you more, because usually they're like a buck each or something for extra shot. It's outrageous. So she's like, okay, sure. Turns out she used my saved drink that already had 4 extra shots and added 4 more. So when they handed me the drink, they're like, please be careful. like they were literally concerned. It had 12 shots of espresso in it for this drink. They're like, don't drink this all at once. This is bad. But that was fun. So I'm excited anytime espresso's on sale. All right, so now we have product. Right, now other things we could do with product, right? There's not just, we can have some attributes and we can set and get them here. Other things we can do, like we can calculate some interesting information here. So maybe we have a public method that's going to return a double for get profit. Right? The profit, how much money I'm going to make, is what I'm selling it for minus what it cost me. So I can return the sales price minus the cost to buy. That's how much money I'm making. Right? So now I can also figure out, so if I had a bunch of products in my inventory, I could go through each one of them and say, okay, which one makes me the most money? I want to sell more of that thing. Right? Or maybe the ones that don't make me a lot of money, maybe I want to raise the price of. Right? We can do other sorts of things that are not just set and get. Right? Set and get is the basics that we do for classes, so you can get values back out, and you can set values that need to be set or pass them to constructors. But then you can do more interesting things with classes. And that's what we're doing with our vehicle class, right? You can add some gas to it and you can drive it to simulate, hey, let's see what's going to happen here. It's still not the most interesting class, but we got to start somewhere. So now, though, we have this product class written. It's a beautiful, amazing class. We want to use it in all of our applications. So we put it in a mobile application, we put it in a web application, we put it in a graphical user interface application, and we have this terrible console application where people have to type stuff in. Product is being used everywhere. If now I have a requirement that says, oh, by the way, in Michigan, you have to charge people sales tax for certain types of products, right? Food at the grocery store is not taxed, right? Unless it's been prepared. Prepared food is taxed, but other food is not for some reason. There's reasons. Our tax laws are fun like that. But if I wanted to add the ability to calculate sales tax and say, okay, the sales tax is 6%, I probably don't want to change product, right? Because it's already being used in all of my different applications, and it does what it's supposed to do, and now I need to be able to sell things that are taxable. So what we can do then is we can make a special version of product. We can do inheritance and say, okay, I am a product, but I'm a special type of product. So we're going to add a new class here. We'll call this a taxable product. And our keyword in Java here is extends. So we say, hey, my public class taxable product extends product. That says, okay, I am a product. I'm a type of product. I do all of the things product does, and then I'm going to be special. Okay? So right off the bat, just by saying I extend product now, I can come into my code here and I can say, hey, I want a taxable product. We'll just call it taxable product, I don't know, taxable product equals new taxable product, and then taxable product dot, and you'll see now those methods aren't in bold anymore. The get name, get profit, get quantity on hand, get sales price, they're not in bold, but you can see if you click on them, it says, hey, they came from your Chapter 8 inheritance product package. You've inherited these methods. So all the public methods of your parent class are inherited. So there's a couple different terms people use for this. This is the parent class or the super class or the base class. And the thing that is the special version is the derived class or the child class or the subclass. I like sub and super, like as a subclass and superclass, because we're going to see in a minute, there's actually a keyword in Java called super. So Java refers to this as the superclass. So that's the terminology I like to use. The other terms are not wrong. It's just different ways of thinking about it here. So I can go get all of the public methods, right, that my parent class had and my superclass had. They're all there. I have access to all of them, everything that's public. Now, what I'm going to do is go, what makes me special, right? So I'm going to have a private double for tax rate. That's what makes a taxable product special. It has a tax rate. And then I need a constructor, right? I need a way to create my taxable product. So if I say public taxable product, given a double for tax rate, and then this dot tax rate equals the tax rate, right? We're off to the races. So now I have a tax rate here. Sure. But now let's go and run this. Oh, so I need to give it a tax rate. We'll say, okay, it's 0.06. But now, how do I give it the name and the quantity and the sales price and my cost to buy? Right? I have no way of doing that. Right? So I am a product. I need to have all those attributes, but I have no way of giving them. And it's actually going to crash here in a second if we try and run this. Yep. Taxable product requires a string int double double found no arguments. Uh-oh. So in taxable product, you have to call the parent class superclass constructor. You have to give it the string, the int, the double, and the double. So it's not even going to run for us here. Taxable product doesn't compile at all. So what we have to do is we need to accept those things as arguments as well, so we can hand them to the product constructor. So I need a string for name, I need an int for quantity, I need a double for cost, and I need a double for purchase price. And then I'm going to hand them to my superclass with this super keyword. So super says, hey, superclass, go do your constructor thing, please. Get the name, the quantity, the cost, and the purchase price. So this calls the product constructor. Now, if you're going to call a superclass constructor, it has to be the very first line, because the superclass attributes need to get set first and exist before you can make these subclass attributes and give them values and things, because we might depend on it. Right? I might need to use something from my superclass here in my constructor. So it has to happen first. So all we're doing is we're going to take the arguments and we're just going to hand them off to our parent class, our superclass constructor. Then I can go do my things. Right? Oh, and we also probably need a get here. So I'll insert a getter for tax rate. And tax rate can change, right? It is possible the tax code can change. It's unlikely that it changes thanks to politics, but it could change. So it probably makes sense to have this have a set as well. Right? And again, we should probably do some sanity checking. Right? If my tax rate is less than 0, we screwed something up. This dot tax rate equals 0. Otherwise, else here, we'll set it. And just to make sure you don't give me some really weird, funky value. Like the state's not going to give you money for buying things, generally. I feel like that's probably a good rule of thumb. Okay, and then if we have the code here, we might as well call the method set tax rate. Right? We don't need to do this same logic again twice. And our product should do that as well, right? Or we should take, instead of this sales price, we should call our set sales price method here that does the sanity checking. We should call the set quantity on hand method that does that sanity checking. Right? If we got the method, we're going to use it. Right? Name, I'll just take whatever name you give me. Cost, I'll just take whatever cost you give me. Right? We don't have any sanity checks there. So sure. So we got taxable product. Right? We can set the tax rate. Awesome. We can get the tax rate. Now, we want to change the purchase price, right? When you go to buy something, it costs you the regular purchase price plus the tax rate, right? So what we want to do is we're going to say, all right, I am a version of product, I'm a type of product, but now I have special behavior. I want to change the behavior of get sales price. So I'm going to say at override. So this is technically optional. This is an annotation that tells Java, hey, I'm trying to change the behavior of my superclass. I want to take a method that my superclass does, and I want to change it. So it's going to give us some checking here. So we'll have a public double get sales price. And what that lets me do then is if I typoed something here, like if I say get sale price, it's going to say, no, you're not. You're not overriding something. It's a in-code warning to say, hey, you meant to override something, but you didn't. There is no get sale price in your parent class, superclass. So it does that checking for us to make sure we're not typoing anything, which is really handy. So, okay, I want to change how get sales price works. Now what I need to do is I need to get the sales price and I need to add the tax to it. Right? Well, I don't have access to sales price. Right? There is no sales price attribute that I can get. Because sales price is private, the only place you can access it is in the product class. Well, it turns out the fine folks who write Java realize this might be a problem. That maybe your subclasses, your child classes, might want access to some of your attributes. So there's another level of access. So we have private means no one's but you can touch it. You have public means everyone can touch it, which is generally bad. So there's a protected level of access here that says you and your subclasses can have access to this attribute. So now over in taxable product, I can say, hey, I want the sales price to equal, right, or to take the sales price plus the sales price times the tax rate, right, and I could return that value. That would be the correct taxable sales price, right? So if you call get sales price, I'm going to say here times this. Now, we don't always have access to the classes we're inheriting from. Like sometimes you can inherit from a class in the Java library, and you're not going to go change this attribute and say, oh, you're really protected now because I want access to it. It doesn't work like that all the time, right? So we can't always rely on being able to do that. So the other way that you can do this here, right, is saying, okay, well, the way I get sales price is through a public method, right? But if I call get sales price, it's going to call my method get sales price. And then it's going to be in an infinite loop, right, over and over and over. So if you want your superclass's version, you use the super keyword. You say super dot get sales price, right? Will give me the superclass's get sales price method, not my method that overrode its behavior. So super dot get sales price plus, and I'm just going to do it a second time here, super dot sales price times the tax rate, right? And we could return that value. We can say, okay, give me my parent class's version to get the sales price plus the parent class's version again times the tax rate. So I can get the correct version out without being in this loop here. So super says go do the parent class, the superclass version. Now what's really cool here is if I make a taxable product, let's say, do they tax coffee? Is coffee a prepared food? I feel like they do tax it. I'm trying to remember now. That's fine. We'll come up with something else. So maybe this is a, they tax the K-pods, right? If you make those Keurig cups, because that's a prepared product. So this is a K-cup. Here we're going to buy a 12-pack of them, and they cost like $1 each. Oh, they probably cost us 50 cents each, and we're going to sell them for $1 each. And the sales tax in Michigan is 6%. We got a bunch of things we have to give here, right? But now what's super cool is I can call print product, and I can give it my taxable product. This here is polymorphism. That's one of our technical terms. It's a fundamental of object-oriented programming, is that I can take a child class, a subclass, and I can treat it as its parent class or its superclass, right? The method print product says, give me a product. And we said, oh, here's a taxable product. But taxable product is a product, right? And it has all of the methods. It looks like a product, right? Then what is the super coolest thing here is through the magic of polymorphism, when this runs and we say taxable product, we give it to this method here and we call get sales price, it's going to run the correct overridden version in taxable product. Even though we're saying, hey, treat it as a product here. At runtime, Java's going to say, oh, okay, you are a product, but really you're this special version of product, and your method get sales price is different. I'm going to do your method here that you've overridden, not the parent class's method, which is fantastic. So that way I can have a bunch of products, and it all works for product here. So coffee, 10, 50, 25 cents, $1.50. Here we go. So we get the K-Cup. We were going to sell them for $1, right, with a 6% tax rate. So when it calls get sales price here, it doesn't call the product version. Even though I said it's a product, it says, oh, you overrode that method. Let me give you the version that you actually have. That's polymorphism. So we're treating the subclass as the superclass, but we're still getting these overridden behaviors. This is super cool. You'll spend a lot more time on this next semester if you take 2151. It's a big topic there and how this all works. Some of that magic behind the scenes, but this is super cool that we can change the behavior of our objects, right? And then they work when we treat them as that parent class type. It's really cool. Okay? That's the basics of inheritance. So we are a type of our superclass, and then we can change the behavior either through overriding or just adding functionality. You don't have to override anything if you don't want to, right? If all you do is just add new methods and new attributes, great. That's perfectly fine. Nothing wrong with that. But if you want to, you can also override and change the behavior. All right. So we should write some tests for it, right? We're going to practice our tests. So do you want to do product too or taxable product? We can do either. We can do both. Let's do product. We'll practice the product here. So I'm going to go to my product class. I'm going to right click, say navigate, go to test. Make sure we pick JUnit 4, right? JUnit 4 works with the Ant projects we're doing, not the latest version for whatever reason. Leave these 3 check marks checked. Nothing else is checked and life is good. I say okay. It makes a new file in this test packages here. Now, again, testing the get methods is pretty silly, right? Because we're going to test them like when we test the constructor out. We're not going to do one individual get at a time. So we're going to skip all of those ones. Get. We're going to get rid of. So we're going to have tests for these sets. And then we're going to have a test here, public void, like test constructor. And we're going to do this AAA format. So we're going to arrange, we're going to act, and then we're going to assert. So all the things that we need to create a product, right? I'm going to have a string for the expected name is coffee. We're going to have an int for expected quantity, 10. We're going to have a double for expected cost. What is it, 0.25. We're going to have a double for the expected sales price. We said was $1.50, $1.50. Great. So these are the variables, right, that we are expecting to get back. Now we also now will have a profit, right? Because we're going to check get profit as well. If I know what the sales price and I know what the cost is, we'll have a double for expected profit. Should be my sales price minus the expected cost. Right? That'll be the profit that I'm expecting. Now for act, we're going to call the code. Well, we're calling the constructor code. We're testing that. So I want product equals a new product, given the expected name, given the quantity, given the cost, and given the sales price. Nope. That was the wrong one. Cost and sales price. Expected sales price. Okay, I've made the product. That's the code I'm testing. Now, to see if I got the values out that I expected, I have to call all the get methods. And that's why it's silly to test the get methods separately, because you're going to test them when we go and see did they get the right values here. So I'm going to have a string for the actual name is my product.getName. I'm going to have a int for the actual quantity equals my product.getQuantity. We're going to have a double for the actual cost is the product get cost. and a double for the actual sales price is the product.get sales price. And then a double for the actual profit is the product.get profit. Right? All the gets to see, okay, if I gave it these values, do I get back out what I expect? So we'll go and get all the values out. And then we're going to assert, did they match? So we can assert equals. We're going to assert equals all of these things just down the list. So the expected name, so it's expected first, and then actual second. And then we'll do quantity. Expected quantity. Does the expected quantity match the actual quantity? And then, one more. Assert equals. Now, when you're doing doubles here, remember Java's bad at math? We looked at that. How it sometimes you end up with like an extra millionth or billionth of something here. So when you're comparing doubles, you also need to give it a delta. Like how close is close enough? I think that's like within a millionth here. We'll call that close enough for our cost. We'll do the same for our sales price, and we'll do the same for our profit. So expected sales price, and the actual sales price, the expected profit, and the actual profit. And then we'll run our test. Right-click and test the file. And if it doesn't fail, it passes. So cool, it passed. Now the other ones passed too because they didn't fail. We didn't actually write any code. We haven't tested the sets yet, but it thinks we're okay. So this is the basic test here for the constructor. If I give it the values, do I get them back out? Just like we did here in main, right? I said just eyeballing it. Okay, if I say coffee, if I say this, when I print it out, do I get those things back out? We're bad at this sort of thing, right? We're not good at it. The computer is much better, so we're going to have the computer test it because the computer is better at testing this sort of thing. Right, and then for the test or the set methods here, I'm going to essentially copy this and we're going to trim it down here. So for sales price, I don't care about name, I don't care about quantity, I don't care about cost. All I care about is the sales price. Right? Don't need any of the other variables. And then I'm going to make a product here. So the thing I'm testing is not the constructor. So I'm going to put the constructor in a range. And then for name, I'm just going to give it an empty string. Right? I don't care what the value of name is. I don't care what the quantity is. I don't care what the cost is. And I don't want to give it the expected sales price. I specifically do not want this one here because if it works in the constructor like we already tested, and then I call set, I don't know if it's actually changing anything. Right? So in my act here, what we're actually testing then is my product.set sales price, given the expected sales price. So if it starts off at 0 and then I set it to a value, are we going to get that value back out? Right? Okay, so then we can test this one here. Did we correctly set the sales price to $1.50 for an object, for a product here? Yeah, that one passes. Now, looking at our product class though, right? If we think about this idea of code coverage, did 100% of the set sales price code run in our test? No, because we never gave it anything less than 0. This line of code never ran. We don't have 100% code coverage. So I'm going to come back and give it another test, right? So let's go and do this again. So set sales price, I'm going to copy the whole thing here. And we'll say negative stays 0. Sure. So my expected sales price would be 0 then if I give it like -1. If I say, hey, your sales price is -1, I should get back it stays at 0. Right? So I'm going to test this one here. That one should pass if we did everything right. Okay, I feel good. Now I have 100% code coverage of my set sales price method because this line of code ran and this line of code ran between the two tests. Okay, so we feel good about this working here. And the same thing for test quantity on hand. We're going to do the same thing here, but we're going to change that to quantity on hand. So let me come back here, grab this one. Set quantity on hand. I only care about the quantity on hand. So I don't need any of those ones. We don't need any of these ones. Don't need that one. We can take all of this and move it up into a range. And then we don't need anything other than quantity. Right, so again, empty. I want it to be 0 because I'm going to go and set it later to something else. 0 and 0. So then we're going to call product.set quantity on hand and set it to the expected quantity. Did we actually get it back out? Okay, let's give that a run. and that one passes. All right, life is good. We passed that one. We still don't have 100% code coverage, though, because we have that exact same test here, right, where if it's less than 0, we stop at 0. So we can come write one more test. Right, so negative stays 0. So using nice names for your tests is important, because if the test fails, you can look just at the name real quick to see what went wrong in your code. Right? Just like naming variables nicely is good, naming your test methods nicely is good too. So we'd expect it to be 0 if I set it to -1. Right? Just like our other one. We'll give that a test, see if that works for us. And this is good because it's really easy when you're like typing these things out to miss a less than and make it a greater than. Right? Those sorts of things. It's easy to run into mistakes. Just like when you write an English paper, you know what it's supposed to do, and sometimes you just typo it. Right? You know how to spell. Sometimes you know how to spell words. Other times you're just guessing, like I do a lot. But you know what it's supposed to say, and sometimes you just have that same word in there twice, or you miss a word. So it's worth testing our code to make sure it did what it was supposed to do. Now, we're not guaranteed to have bug-free code here, though, just because we have 100% code coverage. We're much more likely to have bug-free code, but it's possible we screwed it up twice. Right? I screwed it up when I wrote it, and I screwed it up when I tested it. It's happened, right? I'll raise my hand and say I've done that before. Right? These things happen. It's okay. That's another reason, like, unit testing is not the only testing we rely on. It's a good starting for testing, making sure each of the units work, but there's also other levels of testing in software that happen, which is really cool. Okay? So that's the basics for inheritance here and polymorphism. How you folks feeling so far? You doing all right? Cool. So why don't we call it a day for now? We'll take the rest of the time to work on project 3. If you got any questions on that, and then come Monday, we'll pick it back up. We'll pick this up again, look at it some more. And just as a heads up, because we're not covering all of Chapter 8, my idea here was to just not do a quiz on Chapter 8, because we're only essentially doing like the first half. So I could go through and like pull out just the questions that relate, but again, we're just kind of introducing the topic. We're not going super deep on it, so I don't even think we need to bother with a quiz on it. We'll be using inheritance when we do our graphical user interface applications. Okay, so that'll be about the extent that we're going to use it. All right, and the exports from Twitch to YouTube are still broken. It should be getting fixed eventually. I think Twitch will get around to it at some point. So the links that I'm putting out in the lecture archive section here are links to the Twitch recordings, just FYI that, and they don't seem to load quite right in our page here. So just click open in a new window and it'll open up in that other tab and we can go from there. So hopefully they'll fix the YouTube thing for me soon. So if you're hanging out online, just send me a message on Discord or email, call, text, get my attention. I can hop on a screen share till the end of class or something. Don't forget the study group sessions, Tuesday and Thursday. We already missed Tuesday, 1 to 2. And then individual tutoring sessions. If you can't make the group tutor ones, you're welcome to do that as well. Just ask them to shoot me a note saying that you attended that week. If you made one of the individual sessions rather than the group session, because I already get lists from Tim every week for the group sessions. So just let the individual tutor know. And Tim does tutor out of Southfield on Saturdays. So each campus has its own academic support center with its own scheduling and budget and crazy stuff like that. So he's hooked up at Southfield for Saturdays. He's here at Orchard Ridge on Mondays. It's a whole crazy thing. There's also Rika who tutors for 1,500 as well. Yeah, I Am Wolf. The group tutor sessions are on Zoom. Yep. So the link is here in D2L. You can click the little calendar event here. It has the link for it, or you can go into the content section, and we've got that in the course info here for the group tutor sessions. So if you want those links. Yep. And I'll get you a bonus point on the quizzes. So because there's no quiz for Chapter 8, I'll just give you another bonus point on something else. Because there's not going to be no quiz for Chapter 8. So if you do attend one, I'll just throw your point somewhere else, okay? All right, folks online, take care.